Let's look at the distance formula. Meaning we're trying to find the distance between 2 points. Here's our formula. Please note that you will have to memorize this formula, dual credit. You will not be given this formula on any test. So it is d equals the square root of x2 minus x1, so I'm finding the difference of my x values squared, plus y2 minus y1, so the difference of my y values squared. This should look familiar. Well, let's see how you can construct that formula. Where does it come from? I need to find the distance between these 2 points, 2, -9 and -1, 4. So let me go ahead and graph these points. Hopefully, being in this class, you should know how to graph coordinates. So 1, 2, going down 9, right here, and -1, 4. -1, 1, 2, 3, 4. There's my 2 points. My goal is to find the distance between those 2 points. So this red line here. But as I look at these 2 points, you can't just take a ruler and just measure it now, can you? But I can measure what is my change in my y here. So I can look at what is the difference between that y value and my other coordinate. Like so. I could also look at the change in my x. What is the difference between this coordinate being right here on the x compared to right there on the x? And notice, what did I just form? I formed a right triangle. Where I can see that the distance I'm trying to figure is my hypotenuse. Well, we know how to find the hypotenuse of a right triangle, and that is the Pythagorean Theorem. A squared plus b squared equals c squared. Where c is my hypotenuse, so I'm trying to solve for c. So how do you get rid of a square? Square root both sides. And what do you know? There is the distance formula. I have my a, my change in my x values, square, plus b, which is the change in my y value, square root equals c, which is the distance. So that's where this formula comes from, the Pythagorean Theorem, after we create a triangle with our points. So let's go ahead and use these points and plug them into our formula. So I'm going to call this 1 and this 2. It's very important you keep track of what you're going to call 1 and 2. But note, it doesn't matter. I could call this 2 and this 1 just as long as you keep all the 1s together and all the 2s. So this is going to be my x1, my y1, my x2, my y2. And I'm plugging it straight into my distance formula. D equals square root of x2, so -1, minus x1, 2 squared, plus y2, which is 4, minus y1, which is -9 squared. Now I just need to do the math to find d. So that equals square roots of -3 squared plus 2 negatives makes a positive. That is a 13 squared. -3 squared is a positive 9. Please, if you were to square a negative in a calculator, make sure you put parentheses. Otherwise, it's going to give you the wrong answer. And then 13 squared is 169? 169. So adding that together gives me the square root of 178. Right? Yeah. Now, in the purpose of connect math, you want to make sure you keep it in exact form. If I try to simplify the square root of 178, well, that gives me 2 goes into 178, 89 times, which happens to be prime. So my prime multiples of 178 is 2 and 89. Well, I'm looking for pairs. I don't have any. So the square root of 178 is already simplified. Again, for the purpose of connect math, My math lab, you want to keep it in exact form. But if I tell you the distance between my house and Cypress Park High School is the square root of 178, that doesn't make sense, does it? So in the case we're talking about distance, it is okay to have decimals. So the square root of 178 is approximately 13.3. So if I tell you I'm 13.3 miles, that makes a lot more sense than if I tell you I'm the square root of 178 miles. So in your Schoology assignment, you could probably expect both, I believe. Decimal form and exact form. But note that my math lab likes exact form. So about 13.3 is my distance between these 2 points. Again, we're looking for the hypotenuse. So using this formula, let me give you a moment. Find the distance between these 2 points, 5, 9, and -7, -7. I'm going to call this my left side 1, my right side 2, just because, doesn't matter. So this is my x1, this is my y1. This is going to be my x2, and this is my y2. Let me plug it into my formula, where d equals square root of x2, so -7, minus x1, 5, squared, plus y2, -7, minus y1, 9, squared. All right. So that gives me the square root of -12 squared plus -16 squared. So that is 144 plus 256, which is the square root of 400. And the square root of 400 is 20.
We can't just plug it in the calculator?
Plug one in the calculator.
Like the equation? Or what the...
All of this?
Yeah.
You could. I would just be very careful.
Why?
Because just make sure your parentheses are in the right order and your minuses are set up correctly. Just make sure your math is, make sure if you get it wrong, it's not the result of your typo on the calculator. That's what I'm trying to say.
What's the formula called?
This is a distance formula. Okay? Now what if you aren't given the coordinates, but you're given a graph? I need coordinates for my distance formula. How can I grab those from the graph?
Start point and point.
Point and point?
Point and point.
So give me one of my endpoints.
Negative.
I see 3 and -5.
0, wait, -2, 0.
And what?
-2, 0.
Very good. And -2, 0.
So you just go from there?
Yep, just go from there. Now find the distance. Alright, so let's see. Find the distance between these 2 points. D equals the square root of, I'm going to call this x1, y1, x2, y2. So x2, 3, minus x1, -2, squared, plus y2, -5, minus 0, squared. So that gives me the square root of, 2 negatives makes a positive, 5 squared, plus -5 squared, which is square root of 25, plus 25, which is the square root of 50. Now, again, square root of 50 miles doesn't make much sense. So let's get an estimate. It is roughly, the distance is 7.07.
So why do like all of this when you could just like plug it in?
Plug what in?
The equation.
What equation? You mean all this?
Mm-hmm.
Well, I'm just showing you the steps.
Oh.
If you want to plug this on the calculator, that is perfectly fine.
What's the answer?